Today we're working on 1.4. 1.4 deals with adding fractions. Yeah, adding fractions is fun. So, if I had 3/8 plus 1/8, then I end up with 4/8. So, here's what's going on. If we had a pizza that was cut into 8 pieces, and another pizza that was cut into 8 pieces, and your parents don't tell you it's dinner time, and then when you come up for dinner, because you live in the basement because your parents don't like you. So one pizza has, and it's the one with pineapple that nobody likes. It has 3 pieces left. And then the other pizza has 1 piece left. How much pizza is left? Well, there are 4 pieces. So 4/8. Now, that's only possible because these denominators are the same. You guys understand that? What if they're not the same? You have to make them the same. So if denominators are the same, then you just go ahead and add the numerators, but nobody is going to list the answer as 4/8. How much pizza is really left? Half of a pizza. Okay? All right, good job, guys. What if I had 1/2 plus 1/3? So let me draw this. So we have a half a pizza, and then I don't know why, but they cut this pizza into thirds. So what's wrong with this? 2/5. Colin? What's wrong with 1/2 plus 1/3 equals 2/5? Yeah. So 2/5 is actually smaller than 1/2. So if you had half a pizza and a third of a pizza, is there any way you're going to end up with less than a half a pizza? No. That's true. So what do? Well, we find a common denominator. What does that do to the picture? Money? It makes all of the pieces the same size. Right now, my half of a pizza is larger than my third of a pizza. So to say I have 2 pieces is kind of true, but the pieces are different sizes, so it doesn't really make sense to do it that way. So I need to find a number that 2 and 3 both go into. What do they both go into? 6. So I want to change the problem to this. So in this first pizza, I'm going to cut into 6 pieces. And this one I'm also going to cut into 6 pieces. How many sixths are there in that first one? How many sixths are here? 3. So 3/6. And then the other one? 2/6. And now I get 5/6. Wow, that's interesting. Does that make sense? So, how do we do that numerically? Because we don't want to draw a picture every time we need to add fractions. So, I look at the 2 and the 3. What do they both go into? 6. So, what do I need to do to this so that the denominator is a 6? Multiply by 3. Now, if I times the bottom by 3, I have to times the top by 3. And then I get 3/6. And on the other side, I need a 2 and a 2. Does that make sense? Okay. Let's do one that's a little bit harder. Let's do 7/10 plus, let's do minus 4/15. They do. Now, one thing you can always do is 10 times 15. So you could always say 150 and 150 and then times this one by 15 and times this one by 10. That will always work. But you're going to end up with numbers that are larger than they need to be. So instead of doing that, I find the least common multiple, and Monty knew it was 30. What if you don't know? Write out their factors. So 10 is made up of 2 times 5, and 15 is made up of 3 times 5. Oh, you could. That takes a lot longer, but that would work. Yeah, because you might, what if they don't have one until you get to 150? That might take some time, but that totally will work. So, my common denominator has to contain the largest number of any factor on either side. So, this one has a 2, so it has to have a 2 in the answer. And then a 3, and then a 5. So 2 times 3 times 5 is 30. Okay? What do I need to multiply this by to get to 30? 3. And look at this. That's the only thing that this is missing, is a 3. So that would be, oh, I don't want 150. So that would be 21 over 30. Okay? What is this missing? A 2. And that would be, that's subtraction, so 13 over 30. Does that make sense? Okay. All right, what about 7 over 18 minus 5 over 12? What goes into 18? Factor it out all the way. So 2 and 9, and the 9 turns into 3 and 3. So 18 is 2 times 3 times 3. What is 12 made up of? 2 times 2 times 3. A 4 and a 3. Okay? So my common denominator has to have the largest number of 2's and the largest number of 3's. So my common denominator is 2 times 2 times 3 times 3, which is 4 times 9, which is 36. Do you guys understand that? Okay. So this is going to be 36, and this is going to be 36. What is this missing? What is this list of factors missing from here? Just a 2. So we times this by 2. What is this list missing? A 3. So we times this by 3. And I get negative 1 over 36. Okay? Now, some of you are working ahead, and that's cool, but watch this one, please. What if I had 5/6 plus 2/9 minus let's say 11/15. 9 doesn't go into 30. So let's write out the factors. 2 times 3, 3 times 3, 3 times 5. So my common denominator has to have the largest number of each factor. So it has to have how many 2's? 1. So it... What? Would it be what? Oh, I don't know. How'd you get that so fast? Oh. So you are going to have to do these without a calculator, without, don't type the fractions in, because we're going to be doing things with fractions that you need to understand. So don't do the easy way today. But I need a 2. How many 3's do I need? 2 3's, because the largest number of 3's is a pair. And then a 5. Well, 2 times 3 is 6, times 3 is 18, times 5 is 50, and 40 is 90. Okay. What is the first fraction missing? The first fraction has a 2 and a 3. What is it missing? Does everybody see that? It's missing 15. So I times by 15. That would be 50, 75. Okay. What is this missing? A 2 and a 5. So that would be times 10. So that would be 20. And then what is this missing? A 2 and a 3, which is a 6. So 75 and 20 is 95. Oh, because I'm not paying attention. Thank you. All right, 95 minus 66, that would be 35, 29. You guys understand that? Does that simplify? 29 is prime, so no. Okay, let's look at the assignment for today. Oh, that's not what I wanted to do. Maybe it is what I wanted to do. I don't think so. Oh, I guess so. Okay, simplest form. Find the least common denominator. All right, you guys can handle all that stuff. Okay, that is 1.4.